Let's jump into Pandas methods for working with dates and times. So Pandas can go far beyond just converting strings into numbers. It can also work with dates. Eastern Europeans prefer to format dates in the date, month, year order. For example, March 8th, 2019 would be written 8th of March 2019. In the US, however, it's the month, day, year format, meaning the Eastern European version of March 8th would appear as August 3rd. Okay, so why can't we scroll down here? Regardless of any possible issues that may arise with date translations, Excel is still able to understand both points of view. However, it still can't manage to process absolutely everything. When you're uploading data from a database, you might have formats such as 2019, 803, and so on, and Excel definitely won't be able to untangle that spiderweb for you. Whatever the case, you'll have to be able to enter the dates and times in arithmetic operations. Python has an exclusive data type for that, date time. All we have to do is to make sure to do is convert our strings. Okay, so imagine a situation where an employee is regularly late to the daily 11 o'clock meeting, not wanting to miss out on their bonus. They promise they won't be more than 10 minutes late from this point on. 2 weeks have passed, so let's pull the database from the access system and see if they've managed to keep their word or not. The date column records the time the employees arrives, and the target time column is when they were supposed to arrive at the meeting. Let's check the data type of the date column using the info method. You can see that the date column is currently strings. They use the to date time in order to convert the contents of the column into dates Python will understand. Okay, and they just give you some examples of how you can convert things into date times. So they go ahead and look to see if the data looks any different after calling. There are all kinds of different ways to represent dates and times, but a particularly uncommon one is the Unix time format. The idea is simple. It's the number of seconds that have passed since 0000 on January 1st, 1970. Unix time corresponds to Coordinated Universal Time, or UTC. Here's an interesting fact. You know why UTC is called that? In English, it's Coordinated Universal Time cut. The French, however, call it Temps Universal Coordonné, TUC. So just to make sure neither the Brits or the French fought it, they eventually agreed upon the neutral UTC. The first number represents how many days passed between January 1st, 1970 and March 8th, 2019, whereas the second is representative of the number of seconds in a day. In Unix time, dates and times are stored as integers, increasing with every passing second. Here's what this does for us. Storing dates and times as integers frees up hard disk space. It also makes dates and times easier to run through arithmetic operations. Dates as integers are easier to use as a common format. The toDateTime method will work with the Unix time format as well. The first argument is the column with Unix times, and the second argument is the unit. It has the S value. It conveys the message that the time needs to be converted to the standard format down to the nearest second. We often have to study statistics according to month. For instance, in order to make a record of how many minutes late an employee was on average, to do this, we will enter into the datetime index class and apply the month attribute. So now I'll get to the actual lesson here, or the exercise. Okay, so they want us to read this file on search engine rankings for the past 3 months and print the first 15 rows. So they already read from the CSV for us. We just need to do print position dot head 15. And check that. The level has been increasing over time. Okay, so now they want us to check in general information about the data, so we can print position.info. And check it. Correct. Now process the time data in the timestamp column by converting it from string type to date times 64. Use a capital T as the data and time separator, and then print the first 5 rows in the position table. Okay, so they want us to do position timestamp is going to be equal to position, or I guess PD dot to date time, and then we put in position timestamp. Print the first 5 rows, position dot head 5. Okay, let's check it. Great, and I didn't ever use this capital T. I think that must be the default. So next. Make sure that the data type changed from object to date time 64. So now we can do, you can see they actually wrote out I guess this is the correct way to do the, well, they didn't use the T either though. Oh, maybe here they did. You see the separator? So maybe that's the preferred way to do if you actually input the format. Okay, but position.info, we can print that and we should be able to see that the type changed. Position.info. You can see now that timestamp is date time 64 nanoseconds. We check that. Correct. Next, print the position table sorted by the level in descending order. So we print the position dot sort values by equals level ascending equals false. Yep, so it goes 9876, so we'll check that. Correct. Next. Add the month column to the position table using the month number. Print out the first 5 rows of the position using. Interesting. How do they want us to do that? Oh, I know. So you can do position month is going to be equal to position timestamp dot month. Print position dot head 5. So I thought that you should be able to do dot month. Let's see how they do it in their examples. Scroll, 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 scroll. So much learning. This is what we read before. Okay, here we go. So, yeah, we want to do pd.datetimeindex.month. Okay. pd.datetimeindex timestamp.month. That seemed to work, and the month is now 2 here, and we can see that February is listed there, so let's check that. Correct. Next. Group the data according to month. Oh, what'd I do? Nope, no need for anything there. Okay, and then we do so we do print position dot group by month. The average is going to be the sum divided by the count, right? Typo here, position. Average level for the individual month. So I guess we should get the level here. So let's see if that'll work. You probably have to just print the level column. Let's do level. Check that. Nice. Here we go, try accepts. So when you're uploading data from various systems, be prepared for a surprise. Incorrectly formatted data can cause issues executing the code. This is generally what's referred to as a crash. You already have a bit of experience with that. If the numbers in the data set are strings for whatever reason, then you should already know how to call the toNumeric method. Errors can occur closer to the end of the file with the code not executing for the lines with incorrect values. That means we lose our calculations for the previous error-free lines. Data sometimes changes. For example, when the company adds a new supplier, some bad data could be uploaded for accounting, which will cause the code to crash. Unfortunately, it's impossible to predict all the problems that may occur, but we can't just hit the pause button for the code every time it stumbles upon a bad value. There is a function called try except that we can use when we're working with unpredictable data. You can add the source code to the try block, and if there's a problem with it, the code in the except block will be executed instead. So let's start with some code that we know has a mistake in it. So they're trying to do 1 divided by 0, and as we know, that's going to be infinity. So you have a 0 division error, division by 0, you can't divide by 0, so the code crashed. We didn't even get to see our good afternoon since it followed the line with the error. Now let's do the try except. So it still prints, there's no like error thrown, and it still prints check the values of the parameters A and B. By the way, good afternoon. Although it can't execute the command in the try block, it still won't crash even after the error. It only executes the command in the except block, succeeded by the remaining directions as if nothing ever happened. So we often agree on an upload format ahead of time, which helps us avoid future problems with erroneous data. In our case, the developer sent us over a format we agreed on. The search ranking for a website on a specific day. Write a loop that will count the number of rows in the data, print the results. That will count the number of rows. So we do count lines plus equals 1, and they want us to print count lines. Why is it saying that this is incorrect formatting? I don't know why the print's in red there, but it looks right. Check that. There are faster ways to add that up, but try to remember that's the only tip of the iceberg, okay? So find the average search ranking for the previous period. Print the result. Oh, you have to hit next first. Okay, so let's scroll up to the top here. Did they not even read from that file? Save the search ranking. Oh, so it's going to be row position 1, right, is the level. Row position 1, or I guess index 1, right? Because 0 is the date, 1 is the level. And the total position is going to plus equal the level, right? Okay, and so then the average is going to be total position divided by count lines. Okay, so level is a string, so we first need to convert it. So we can do int around it, which will convert it to an integer. Let's check that. Great. Next. See how we can scroll down here. We agreed on how the statistics are to be delivered and developers send over the final upload. Although there seems to be quite a few problems with the data, negative values, gaps, and even some more errors. Calculate the average search ranking and run the code. Afterwards, comment out your solution and click check. I guess I didn't hit next here. Oh, so you see they have like error 5 and stuff in here. So the level is, we're still going to do the same thing. The level is going to be equal to row at position index 1. And the total position is going to plus equal the level, int level. So you see we're trying to cast everything to an integer, but this error 5 is going to not actually be able to be cast, so it's going to throw an error there. And so if we try and print row, or I mean total position divided by count lines, it's going to throw an error. My indentation is also wrong. It's not the thing we were supposed to have happen. Let's see. Why is that indentation wrong? Oh, because this was tabs and that was spaces. That's weird. There you go. So this is what we're supposed to get: invalid literal for int, -6. It's not going to work. So they said comment this out. And then check it. Oh wait, comment out your solution and click check. So comment this out. Click check, question mark. Okay, so next. Use the try except and process the errors that are preventing us from getting the job right. Print the total number of rows in addition to the number of erroneous lines using this format. Okay, so we need to put a try block in the for loop. Okay, and then we need to do except underneath it. Okay, and so if there's an exception, that means we can add 1 to the erroneous rows. Erroneous rows plus equals 1. Okay. then we can do print total measurements, and then comma count lines. We can do print total erroneous rows, comma erroneous rows. Okay, and check that. Great, next. Now task 5 is saying we need to go beyond our understanding of how many mistakes we have on our hands in order to find out where they are. Add the ability to make a list of erroneous strings. Print the total number of rows in addition to the list of problematic rows using this format. Okay, so we can do wrong lines content dot append, and we want to append the whole row, it looks like. So then we can now print both these lines they want us to print, which are print total measurements, comma count lines, and then print wonder if it's okay with us just printing that list. We'll see. We do erroneous, because we might have to do a for loop instead to print each line individually, but I think this might work. Erroneous rows, colon, comma, wrong lines, content. Let's see if it likes that. Great. So I'm going to work on the merge method. So we drew our first conclusion. We received twice as much organic traffic as opposed to direct user visits. However, that's not the end of this epic saga. We still have to study the traffic for each product category. The data has been stored across multiple sheets in the Excel table. How can we see categories, subcategories, and traffic in the same area? Here's an idea. Let's put the tables together. We can combine multiple tables using the merge method. Merge is applied to the table we're adding other tables to. Here are the arguments for that method. You can do write, which is the name of the data frame or series we're joining to the main table. On is the name of the common list of the two tables we're combining, which is what I used to combine them. How is which ID values to include in the resulting table. The how argument can have a left value in which case IDs from the left will be added. The right argument pulls every ID from the right table. Let's combine the data and subcategory dict tables that we have the following conditions. Data, the table we're going to be connecting with the other. Subcategory dict, the table will be joined to data. Subcategory ID, the column common to both tables we'll use to merge them. How left, the ID values in the data table will be added to the resulting data subcategory table. Okay, so we want to combine the subcategory dict and data tables by yourself, save the results to the data subcategory role, and print the first 10 rows. Okay, so we can do data underscore subcategory is going to be equal to pd.merge. The left is going to be data, and the right is going to be subcategory dict, and then we can print data underscore subcategory dot head 10. Check that. Okay, potentially it wants us to do the exact same left and right things they had up here, so I guess they want how is, let's do on equals subcategory ID and how is going to be equal to left. Let's check that. Great. Next. Merge the data subcategory and category dict table. Show story results to the data final variable and put the first 10 rows of the new table. Okay, so data final is going to be equal to pd.merge. The left is going to be data subcategory. The right is going to be category dict. The on is going to be equal to the subcategory ID, and the how is going to be equal to left. And they want us to print data final dot head 10. Okay, it looks like they don't have the same on point. So let's see, let's print what category dict has in it. It's just category ID, I guess. That seemed to work. We'll get rid of this. Check it. Correct. Next. So this video is getting kind of long, so I'll stop it here and we'll do pivot tables next time. Thanks.